And today's lesson is going to be really quick and really easy. It's all about slope. We're probably going to spend more time going over last night's homework than we really even going over today's lesson, because we're just stealing this from algebra. This is all from algebra. This unit, unfortunately, has a lot of algebra in it. We'll get back to geometry, I promise. So go ahead and rank the slopes from flattest to steepest. Would anyone like to request screen control, and you can actually grab those numbers and put them in the correct order? Okay, I accepted the first person who requested. You're going to have to leave some room. You're going to have to scoot those over. Rishi's doing it, by the way. Interesting organization down there. Johan, don't steal Rishi's thunder. Okay. Very nice. Thank you. Okay. So 0 would be our flattest. And so pretty much Rishi just ordered them from the smallest number to the largest number, ignoring the negatives. Because the negative doesn't impact flatness or steepness. It just impacts like which way the line is going. So that was very good. 0 is the flattest. This is 0. And then 7 is the largest number that was up there. So 7 is the steepest one. So the flatter the line, the smaller the slope. And the steeper the line, the larger the slope. Okay? Let's check over your homework, because that was a very intense homework. And I hope everyone tried all 12 problems, because we have a quiz over this tomorrow, and you needed to have tried all 12 problems. Number 11 was a doozy. It was interesting. Number 11. Did it take you a while to do? Thank you for investing your time. We're going to start with number 5. This one will be really quick, okay? Because we're going to be able to see the pattern right away. So the way that you start these is it's not going to be labeled on the quiz. It's not going to say, oh, this one's exponential, by the way. And so you're always going to have to start with delta y. So you're always going to start by subtracting. So you get 20, you get 100, you get 500, and then you're like, well, that's not constant, so I better do it again. So you get 80, and then you get 400. And then you ask yourself, what number are these being multiplied by to get the next one? You can divide them. What's 100 divided by 20? What's 500 divided by 100? What's 400 divided by 80? It doesn't matter which two you pick. You can pick any two of them that are consecutive, and you're going to get 5. So you know that 5 is your base. It's not your coefficient. That's a different word. 5 is your base. It's not your coefficient, okay? So be careful. 5 is your base, and then you just play with it. Well, on this one, if I raise it to the 1, to the 2, to the 3, I don't have to tweak it at all. Like that, I'm done. 5 to the 1 is 5. 5 squared is 25. 5 to the third is 125. So now all I have to do, 5 to the n is my answer. And now I just need to find out what 5 to the 6 and 5 to the 5 are. So you do 5, and you do the caret button, and then you do to the 5, and then 5 to the 6. And so that would be your 5th term and your 6th term, okay? Okay. So that one was really quick. Now I'm going to do number 8, and this is going to be a quadratic with a middle term. This is the only one I'm going to do like this, so make sure you're watching with your full attention if you still don't get this from yesterday. Make sure you're giving me all your attention right now, every ounce. 10, 18, 28, 40, 54. Okay. All right, so we do delta y, and we get 8, 10, 12, 14. We do delta y, and we get 2, 2, 2. We now know it's quadratic because we got a constant number for delta y. So now we do the 2-2 rule. It says take your delta y, divide by 2, and square your term. So if I divide 2 by 2, I get 1. And then I square my term. 1 squared, 2 squared, 3 squared. 6 squared and n squared. I didn't write the 1 because it's understood right there. The next step you don't write down because this is not part of your pattern. It's not part of your equation. This step is when you say, what do I have and what do I need? I have 1 times 1 squared. I have 1. What do I need to make 1 look like 10? I need plus 9. In the next one, I have 4. 2 squared is 4. What do I need to make 4 look like 18? Plus 14. Let's do it one more time. In the next one, I have 9. What do I need to make 9 look like 28? So if you don't know that off the top of your head, you do 28 minus 9, and you get 19. Our middle term comes from the change in the what do I needs. I wrote down the what do I needs. They're right there, 9, 14, 19. I need to find the change in those numbers. Change just means subtract. So 14 minus 9, 19 minus 14. So I get 5 every time. So 5 is my middle term. 5 is the change in the what do I needs. Our middle term, you just write the plain old term. It's not squared, it's to the power of 1. So far, we have n squared plus 5n. That's what we have so far. Don't write the answers. Okay, so now we take inventory. What do we have and what do we need? So in step 1, we've got 1 squared times 1, so we've got 1 plus 5. We have 6. What do we need to make 6 look like 10? Plus 4. In the next step, we have 4 plus, let's see, 5 times 2, 10. 4 plus 10 is 14. How do you make 14 look like 18? Oh, good. So we're done. We checked it twice like Santa, so we can write it all the way down the column. And so it's n squared plus 5n plus 4. And then when you plug that into your calculator, what do you get, 70? Okay? All right. Next one that we're going to do is, 10 and 11, and then we'll move on to today's lesson. Number 10. Okay. As usual, you fill in your values and you do delta y. So you get 2, 6, 18, 54, and then you get 4, 12, 36. Oh no! Delta y is not constant. So boom, it's not linear, it's not quadratic, it is definitely exponential. So now we see if dividing those numbers give us any clarity. Let's start dividing our delta y's and our delta y's. 6 divided by 2 is 3. 18 divided by 6 is 3. 54 divided by 18 is 3. We're getting 3 every time. That's good news. That means our base is an integer. Our base is 3. Not our coefficient, but our base. Now, if we start putting our term in there, we run into a problem. Because 3 to the 1 is not 1, and 3 squared is not 3. Let's do something. 3 to the 1 doesn't equal 1. How do you make 3 look like 1? Well, minus 2. 3 squared is 9. How do you make 9 look like 3? Uh-oh. I'm getting a different number. I can't get a different number. That's not how these patterns work. So I know that tweaking it by just adding or subtracting a number is not going to work. But then I stare at it a little bit longer and I notice something. 3 to the 1 is 3. 3 to the 2 is 9. 3 to the 3 is 27. Do you see how they're equaling the very next value? So how I can fix that, how I can shift them all down 1, is just by subtracting 1 from the term. I want them all to shift down 1. It's not a lot of things to remember. I see what you're typing. It's just, you're just playing with it. You're just looking at the numbers. You're not memorizing anything. How did I get 3? I took these and I just divided them. 6 divided by 2, 18 divided by 6, 12 divided by 4. You don't have to divide all of them. You get 3 every time. They're multiplicatives of 3. They're being multiplied by 3, not multiplicatives. All right, so if I can take my exponent and just subtract 1 every time, then I'm going to be where I need to be. That's going to be 3 to the 0. That's going to be 3 to the 1. That's going to be 3 to the 2. Does that work out? What is 3 to the 0? 1. 3 to the 1. 3. 3 squared. 9. Oh, we got it right. So our nth term is 3 to the n minus 1. Let me show you that much more clearly. It's 3 to the n minus 1. The minus 1 is in the exponent. That's different. So how would we find the 6th term? 3 to the 6 minus 1 is really 3 to the 5th. So you would just go in your calculator and you would put 3 to the 5th and you would get 243. All right, last problem. Ready? The toughest one. Number, where is it? Sorry, 11. So yes, you could totally see one like this on your quiz. So right now I'm going to tell you no complaining, okay? Math would be no fun if you were never challenged. We have to push you. We have to challenge you. That's how you get better. All right, so we do delta y and we get 1, 7, 55. Oh no, this is not looking good. And then we do delta delta y and we get 6, 48. Let me go ahead and finish this one out. 625 minus 64. This is 561. And so now, normally we would take our delta y and our delta delta y and we would divide them to find our base, right? Okay. Normally that's what we would do because that works when our base is an integer. But if you start dividing these, 7 divided by 1, 55 divided by 7, you don't get the same number every time. You get just gibberish, right? You get numbers that make no sense. When you divide all of these out, there's no common theme, okay? And so that is when you know that your base is not an integer. Your base is n. N is your base. N is your base. So my base is 1, 2, 3, 4, 5, 6. So now I need to see what the power is. Try to the power of n first. Try n to the n first. 1 to the 1, 2 to the 2, 3 to the 3, 4 to the 4, 5 to the 5, 6 to the 6. And then see if you need to tweak it. Now 1 to the 1 is 1. That one works. Oh, but 2 to the 2 is not 2. And 3 to the 3, that's not 9. So we're in trouble. So what do you think we should try next? Right, I mean, I showed you the answers, right? Okay, so you have to try to tweak the exponent because tweaking the whole number is not going to be good enough. We need to try to tweak the exponent. Now, 1 to the 1 is 1. But what else could I raise 1 to that would also be 1? 1 to the 0 is also 1. And so maybe we could do like we did the last problem, and maybe we could play with subtracting 1. Let's see where that would put us. That would be 1 to the 0. That would be 2 to the 1. 3 to the 2. Oh. Do you see the pattern? That's kind of cool. It's a number raised to the number that comes right before that number. So let's try it out. 1 to the 0 is 1. 2 to the 1 is 2. 3 squared is 9. 4 cubed is 64. Okay, thank goodness we found it. Okay? So, yes, you're asking a good question. When you divide these and you don't get any common number, that's when you have to just guess, check, and revise. Yep, you are right. You are right. All right, we need to teach a lesson because y'all need to take a quiz. So, quick lesson. Here we go. Oh, y'all are typing and I can't go to the next slide. Okay. Slope. This is a review, so I'm going to go really quickly. You've heard these things. Rise over run. Delta y over delta x. Vertical change over horizontal change. Those should all come to your mind when you hear slope. Here's just a reminder. That's what positive slope looks like. Negative slope. That's what zero slope looks like. Hopefully your teacher showed you could turn that line into a Z. Z stands for zero slope. And then the undefined slope, you could turn that into a U for undefined sloped. So if you get these two mixed up a lot, you can turn this one into a Z and this one into a U. Finding the slope. Okay, we're going to skip those slides because we're running out of time. You can find the slope by counting. First of all, we would stare at this line and we would say that this line has what? A positive or a negative slope? Negative, because as x is getting bigger, the line is going down, 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 down. So we're going to have a negative slope. We know for sure it's going to be negative. So then you just find your points. You find 2 points and you count. Down 1, 2, 3, 4, 5, 6, 7, 8. I went down 8 and over 1, 2, 3. I went down 8, so negative 8 and over 3. This is one way to find the slope. You count rise over run or fall over run, right? Okay? Rise or fall. So our slope, we just leave it like that. Do not put it as a decimal. The slope is negative 8/3, end of story. Never write a repeating decimal as your slope. Okay, that's the graph way. The next way is when I give you 2 points, you can just use the formula. The formula is delta y over delta x. Subtract the y's and then divide it by the subtraction of the x's, okay? So if I give you 2 points and I ask you to find the slope, I would like you to do the same thing that I asked you to do with distance and midpoint. I would like you to circle the x's and underline the y's. So I'm going to do y minus y over x minus x. Negative 2 over 9. Done. End of story. Done. Okay, next one. Circle, circle, underline, underline. Y minus y over x minus x. 0. I don't really care what's under there, even though it's 2a. 0 divided by anything is 0, so the answer to that one would be 0. That one was weird. It was different. It was letters. Okay. Here's one that's a little bit different, and then we'll take our quiz. Find the slope of a line that crosses the x-axis at 8 and the y-axis at negative 2. We might have to do another one after that, sorry. What is the slope of the line that crosses the x-axis at 8 and the y-axis at negative 2? So you could do this 2 ways. You could write this as a coordinate, 8, 0 and 0, negative 2. And you could do it the formula way, or you could sketch a graph and you could do it the graph way. So the rise is what? The rise is 2 and the run is 8. So what would the slope be? One-fourth. You always reduce your slope, always, every time, all the time, reduce your slope. Yes, you have to reduce, always reduce your slope. Simplify, yeah. Okay, I think this is our last one. A line with a slope of 3/4 passes through those points, find y. So this is like yesterday. I'm giving you the answer and you're trying to find the question. It's kind of like Jeopardy. So 3/4 is the slope. To find the slope, you do delta y over delta x. So y minus y over x minus x. So let's clean this up a little bit. 3/4 equals y plus 5 over 8. There are a lot of ways I could solve that at this point. I could cross multiply. So if you love cross multiplying, then cross multiply and it's over. Or some of you like to use number sense. Oh, 4 times 2 is 8. 3 times 2 is 6. So I know y plus 5 is 6 and I know y is 1. So it's up to you whether you want to use your number sense or whether you want to actually cross multiply. If you cross multiply, you get 24 equals 4y plus 20, because you do have to distribute. And then you would subtract 20, 4 equals 4y, divide by 4, and you get your y equals 1.